In the late 1800s, every major factory, hospital, and skyscraper was a ticking time bomb. The age of steam powered the world, but the systems were unreliable, dangerous, and constantly leaking. A small leak at the wrong place could lead to a massive pressure drop, overheating, and a catastrophic boiler explosion. For the plumber, the problem wasn't the boiler. It was the single mundane piece of hardware that failed every single time. It was the valve. To solve this problem, Jenkins Bros put forth a promise in their 1899 catalog that changed industrial safety forever. They weren't just selling brass, they were selling a guarantee against disaster. In this vintage catalog, we will uncover their 3 engineering secrets: their patented disc, their keyed stuffing box, and their ingenious repair method that allowed one small company to solve the most dangerous, costly, and complex problem of the industrial age. We'll show you the competitor failures this valve was designed to replace, the absurd cost savings it created for factory owners, and why this century-old design is still considered a masterclass in reliable engineering today. At the beginning of this 1899 catalog, Jenkins states a guarantee so aggressive, so absolute, no other company in the world would dare print it, which they refer to as their fair offer. It says, if you will put a Jenkins Bros valve on the worst place you can find, where you cannot keep other valves tight, and if it is not perfectly tight or does not hold steam, oils, acids, water, or other fluids longer than any other valve, you may return it and your money will be refunded. They were saying, find the most dangerous, high-pressure, corrosive, acidic, leaky pipe you can find on this planet, and our valve will not fail. That kind of confidence wasn't built on wishful thinking. It was built on a tiny, revolutionary invention that literally prevented the explosions their competitors' inferior valves were causing. To understand the revolution, you have to understand the crisis. Before Jenkins, valves used a simple, awful system: metal ground against metal. This was called a ground joint, or metal-seated valve. High-pressure steam and industrial fluids are brutal environments. The metal expands and contracts wildly under heat. The constant pressure and vibration cause the rigid metal seat to rapidly pit, erode, and grind itself into a sieve. This was a process called wire drawing, and it meant a valve was failing constantly. The result was a continuous stream of leaks, which translated directly into vast sums of wasted steam and wasted money for the factory owner. But for the plumber, the cost was measured in labor and danger. A constant drip meant an engineer was constantly having to regrind the metal seat by hand. The steam line would have to be shut down, cooled, disassembled, and hand-lapped back into a seal. This was expensive, unreliable, and prone to error. More importantly, those chronic high-pressure leaks led to rapid, unstable pressure drops in the boiler system. Any disruption to the boiler's pressure could lead to overheating and, ultimately, a catastrophic structural failure of the boiler itself, the precursor to an explosion. Every plumber knew that a leaking valve was not just an inconvenience, it was a silent threat. The industry desperately needed a seal that could adapt to imperfect surfaces, withstand high heat and pressure cycles, and most critically, be easily replaced. The industry needed something flexible. The simple, genius solution came from Nathaniel Jenkins, who patented his design back in 1864. But by the 1890s, Jenkins had perfected it. They didn't invent the valve, they invented the valve that actually worked under pressure. The secret was replacing that rigid, failure-prone metal seat with a compressible, replaceable disc made of vulcanized rubber or a proprietary composite they called the Jenkins Standard 96 packing. This disc was the true lifesaver. The catalog tells you exactly why on page 6 under the heading, Reasons Why They Are Superior. The first reason listed is, the disc forms the seat making a perfectly tight valve under any and all pressures of steam. Furthermore, they guaranteed that the elasticity of the disc allows it to adapt itself to an imperfect surface. Grit, sand, and tiny imperfections from wear that instantly crippled a metal valve simply didn't matter to the Jenkins disc. It compressed, it absorbed, and it sealed. This was the difference between an unreliable seal and a guarantee against explosion. The Jenkins discs had been greatly improved, as they state on page 3, specifically engineered to stand high-pressure steam, and are superior to anything ever placed on sale in this line. This wasn't just about steam either. Remember their fair offer? It guaranteed their valves would hold steam, oils, acids, water, or other fluids, proving the composite disc was engineered to resist chemical corrosion and heat breakdown in a way metal could not. And the cost of this life-saving innovation? The material for the replacement discs was listed for as little as $1 per pound on page 30. A cheap, quick fix that saved countless thousands in repairs and averted certain disaster. But Jenkins knew a great disc wasn't enough. The surrounding mechanism had to be equally brilliant to make the valve last. The catalog is a testament to the fact that they obsessed over every tiny detail. For example, they improved their iron body valves by increasing the thickness of flanges and adding more bolts, making them suitable for either high or low steam pressure. This solved the problem of pressure warping the iron body itself. They were building redundancy into the very structure of the valve. They pioneered the keyed stuffing box. This patented feature, detailed on page 5, prevented the packing and nut from turning when you opened or closed the valve, stopping a common cause of leaks right at the stem. This small adjustment significantly extended the life of the critical sealing material. But the true quality of life improvement was for the plumber on the job. The catalog guarantees you do not have to take them off to repair them, and they can be repaired by any mechanic in a few minutes. This promise meant the plumber could swap a new disc into a running line, minimizing downtime and saving the factory owner money. How did they achieve this speed? The disc removing lock nut. As you can see in the diagram, the disc and nut were locked together so that when the plumber unscrewed the nut, the worn-out disc came off cleanly. You didn't have to spend time picking and digging out stuck, worn-out rubber. This focus on the tradesman's efficiency is why Jenkins became the trusted standard. But because their technology was so superior and so critical for safety, Jenkins faced a huge problem: counterfeiting. The competition couldn't match the quality, so they resorted to lying. The Jenkins story is a perfect example of a superior technology conquering a dangerous market, but that dominance had to be defended. Look closely at page 6. They repeatedly print a severe, stern warning. Do not accept any valves as ours unless stamped with trademark. They had to spend money on their catalog and marketing just to fight the endless stream of cheap, dangerous knockoffs. This trademark, the diamond mark, wasn't a vanity stamp. It was a safety certification. When an engineer saw the trademark, they knew they were looking at the valve that would not fail, the one that guaranteed safety, not a cheap imitation that would inevitably turn the boiler room into another time bomb. By 1899, the company had established major distribution hubs not just in New York, but in Boston, Philadelphia, and Chicago. They were supplying the new industrial backbone of America, from the steam lines of the Brooklyn Bridge to the plumbing of the latest skyscrapers. Today, the Jenkins name is still synonymous with quality, having been acquired and expanded over a century later. If you enjoyed diving into this forgotten history of industrial safety and the catalogs that preserved it, please consider subscribing. We've got plenty more waiting in the archives. Thanks for watching, and I'll see you in the next deep dive.